This is an ecosystem. This is an ecosystem. This is an ecosystem. And this, when it dies, will be an ecosystem. Hi. My presentation is on Osedax, otherwise known as the zombie worm. But first, I need to talk about whales. As you probably know, whales are the largest animal in the world. Blue whales are humongous. They can weigh around 290,000 pounds to 330,000 pounds. That's a lot of meat. And in the ocean, nothing is wasted, right? When a whale dies, it can, sometimes wash up on the beach, as you see, in those videos like the whale exploding. But most of the time, whales will actually sink to the bottom of the ocean. They'll die in the middle of the ocean, and they'll fall thousands and thousands of feet to the bottom of the ocean. This is called a whale fall. It actually happens a lot. It's just really hard to find. Scientists try to find them, but they don't know where it's going to happen, right? It can happen anywhere in the open ocean, and it's not like a thermal vent where you can just track the rock patterns and just slowly go up and up and up until you find it. This could be anywhere, and there's no clues to it except for the fact that there's a swarm, right? Whenever a whale fall happens, there's an absolute swarm of scavengers. That's why it creates its own ecosystem. Also, that's why a lot of whale bones get completely destroyed, right? You can't find them. Nothing is wasted in the ocean. Most of the time when scientists find whale falls, all the meat's already gone because the meat's gone within at least a month. And they usually find them months after. But as you can see here, even though it takes years, all of the bones are completely destroyed. That's due to Osedax. Osedax here is, you see that red kind of fluffy stuff around the bone? That's Osedax. That's the zombie worm. Up close, they look like this. They are little red worms with, pumes of big furry pumes. The red is due to their blood, just like vent worms, because it doesn't really matter what you look like if you're at the bottom of the ocean. This is super, super deep, by the way, super dark. They were discovered in 2002. When they were found, it was a whole new genus, right? The genus is called Osedax. Osedax in Latin means bone eater. The first extensive report on Osedax was done in 2005 by Shanna Govridi and her associates. The plume at the top, right up there, is essentially the gills, right? In the first report, they talk extensively about how this big thing on the bottom is entirely used to secrete acid. So these worms, like vent worms, do not have mouths or stomachs. How they eat is, and this is also how they burrow too, they secrete acid from that giant little bulge at the bottom. They secrete acid that melts the bone, and then they continue secreting acid until it melts the marrow. Then they have bacteria inside of that little bulge that will break down the marrow to just straight up pure nutrients that the worm can, digest. This is incredibly, incredibly rare, as usually when there is a pairing of bacteria and some other animal, some other host animal in a symbiosis, the bacteria is an autotroph, right? Think coral, where the zooxanthellae can produce from sunlight. This bacteria is a heterotroph. It completely relies on the worm to dissolve the bone marrow for it, and the worm completely relies on it to break down the lipids in the bone marrow into something it can dissolve, right? The trunk in the middle is entirely for mating. That little middle section is for mating. In fact, this up here is part of the ovary of the worm. And the big thing that's really weird is that we didn't know anything about the reproduction until 2013. A paper came out by Sigrid Katz and Greg W. Rouse. It turns out all of these worms, all of the worms you can see, these are females, right? The male worms are incredibly, incredibly small. As you can see here, the male worms hang outside of the female worms by the trunk, right? The male worms, as soon as they're born, have to get to a female worm. They cannot eat on their own. The only way they can eat is by going inside of a female worm through this outside ovary, or hang out into the trunk until they make their way up and then go inside, and then just basically bumming off of the female's nutrients that it's getting from the bacteria. Like it's crazy. It's even more extreme than anglerfish, and this is what a male looks like. Their entire body plan is devoted to basically just being like a kamikaze bomber, but with sperm. Yeah. Another thing that I forgot to mention that these worms have is you see this little lining of mucus around. This mucus, most scientists think that it's a way to protect the worm from its own acid and a way to keep the worm stable if the acid erodes too much bone. It can also, some scientists, fewer scientists, but some scientists believe that it's a way for the males to stay close, and it's a way for the males who are drifting to get stuck to the female so then they can crawl up it. So the entire purpose of the male, go in, and once they basically fertilize some of the female's eggs, they can chill in there. They can chill in there with, as you see in here, hundreds of other males until they die. And then after that, the female will release her eggs into the sea, again using this big ovary pipe. And through that, the female will start a new generation, and the males will just go out, find other females, and the females will burrow into old dead whales.